sort of close this down, and we're gonna work through an example, and we're gonna try to incorporate most of what we did yesterday, just to recap, and hopefully also look at that conjugate pairs here. What on earth, Professor, does that mean? Andrew, you said yes to my first question. Is there also something called intermediate value theorem mentioned?
Yeah.
Wow. I did it all. I thought maybe I'd let that out. So I gotta take a look and see what on earth, Professor, is intermediate value theorem telling you. Okay? So guys, any quick questions though? I keep on asking before I jump into it. Andrew, do me a favor. Did I have under conjugate theorem, pairs theorem, did I have an example to work out to find the zeros? If so, I could use it instead of the one I brought in. Is there one that says find the zeros, find the complex?
Says, yeah, find the complex zeros of the given polynomial function.
There you go. So find the complex zeros. Let's do it. Hang on. Find this. Hey guys, by the way, in preparation for the exam tomorrow, also in preparation for any exam or quiz, please refer to June's notes. My goodness, how do you handle it, her notes? Those are so nice, organized. Okay, tell me what that function was, Andrew, that was supposed to find the zeros.
It's p of x equals 3x to the 4.
Okay.
Plus 5x cubed plus 25x squared.
Oh, wow.
Plus 45x minus 18.
Okay, looks like that. How many zeros am I expecting? What's the degree? I6 one says 4, you gotta get 4.
Yeah.
You gotta get 4. And he used the word complex that says you get 4 whether or not I's show up or not. I get some I's in the answers. So guys, if I use Descartes' rule of signs real quickly, first term to the second term, no change. No variations from the second to the third. No variation here. Finally, I end up with one variation, which tells me of those 4 zeros I'm expecting, I may have one be what? Positive. So this is Descartes' rule of signs. Right here, so just a quick reminder. And for the number of positive real zeros, we have now determined there's only one there. Now, if I want to find how many possible negative real zeros, does anyone remember the rule? What did we have to do to find the possible number of negative real zeros of those 4 zeros I'm looking for?
Do negative x.
Thank you. Got to find p of a negative x. Guys, it merely says go back, replace those x's up there with negative x, rewrite it. If I replace x by negative x in that first term, there's no change. You raise it to the 4th power, stays just like it is. Put it here, negative x cubed. There is a sign change there. Turns into a minus. Or subtract negative 5x cubed. Next one, 25x squared, no change. I replace x with a negative x. 45x, there is a change. And of course, my constant, like that. Count the variations in signs here, guys. From the first term to the second term, there's no mistake. I see one there. From here to here, another one. And from here to here, gee. Another one. Did I count correctly, guys? Are there 3? Are there 3 sign changes there or not? Are there? So what does that tell me about the number of negative real zeros? I could have what, 3 or 1? Okay, so we've got 3 or 1. Okay. Now, here we go. Let's use rational zeros theorem, which really says you're gonna use that P over Q we talked about yesterday. Just try to tie all this together before I leave it. And guys, notice in that word rational is ratio. So they use for the ratio fraction. They like to represent that as P over Q. P should be a factor of which term? Who recalls yesterday, when I did the factors here for P over Q. P was what?
Factor of the constant.
The constant, the negative 18. So I got plus minus 1, I'll write mine like this, plus minus 18, plus minus 3, plus minus 6. Stretch this out, do not leave any out. And I think that's it. The Q, all the factors of 3 by leading coefficient, not too many. Plus minus 1, plus minus 3. Now, I'm not going to ask you to write all the combinations, because there's quite a few combinations here if you take the time to split this up. Like you could say, well, professor got 1 over 1, yes. Negative 1 over negative 1, yes. 1 over negative 1, yes. 18 over 3, yes. Negative 18 over 3, yes. 3 over 3, 6 over 3, 2 over 3, 9 over 3, 9 over 1. Lots of them. I'm hoping though, without you listing all of them, we're looking for, by Descartes' rule of signs, 1 should be positive. 1 to 0 should be positive. So guys, does anyone have a favorite positive possibility coming out of here that maybe works, and I'll test it? Or would you prefer just jump into it, because also it says you may end up with 3 negative real zeros. Or what? Does anyone have a favorite positive? Coming out here is maybe 1 over 1, could be 1 over 3, 8 over 1, 8 over 3. Look at the possibilities here. 3 over 1, 3 over 3, 6 over 1, 6 over 3, so forth and so on. 2 over 3. Lots of possibilities. Andrew?
6 over 1.
Okay, which 6, okay.
Also, you erased the 1 from the 18.
Where was it?
You're saying it's 8 now.
Right here.
Yeah.
That's 18. Now, you're saying, you'd like for me to test 6, was it?
Yeah, 6 over
Let's
1.
try 6. Okay, guys, go back, let's pick up my coefficients and my constant. 3, 5, 25, 45, negative 18. Andrew, I'm not saying you're wrong. Make sure my numbers are written down correctly here. But I think with that big number 6, even when you get started here, what happened? This is 0, of course, always here. You add them up 3. You're going to get 6 times 3 is 18. And this becomes 23. Then you got what? 6 times what? 23? Are the numbers going to get really, really, really large?
Yeah.
And I don't think you're going to end up with something here like an 18. So these two would cancel. So let's try something else. I don't think 6 is going to work. Guys, does anyone have another one in mind?
1/3.
1/3. Let's try 1/3. Okay. Now, did you just randomly choose that?
When I did it in my head, 1 felt too
Oh, you
big,
did?
So,
Hang on. Okay.
hoping.
1/3. Here we go. That's the 3. Yeah, 1/3 of 3 is 1. That's the 6. 1/3 of 6 is 2. 27. 1/3 of 27 is 9. Oh, that's 54. 1/3 of 54, look at that. 1/3 worked. So now, of those 4 zeros, Descartes said find 1 positive, and then my student just helped me. It's 1/3. I didn't make a mistake, did I? Philip, what was that question? Are we okay, guys? Was it 1/3? Okay, now, here we go. Right now, in this set, I know with his help, right there, 1/3 works. Okay, guys, I could stack this up. As soon as you discover one that works. But you gotta find the first one to work, then you're allowed to stack them up. And try now maybe a negative. positive out of the way. Does anyone have a favorite negative? Because there's a possibility it could be one negative real zero. Does anyone have a negative coming out of that mess that I could test? See the issue of this? How much time it takes? You're gonna get frustrated when you see some of your classmates walk out because they got a little lucky maybe and try a number that worked out immediately. Okay, I heard something there. PK? -2, right. 0, 3, -6. Don't let me make a mistake. 0, 0, 27. I think you're right. Is it true? I didn't make a mistake, did I? PK, thank you. Okay, guys, so far so good? But now I take our I got this one. She helped me out this one. And I'm expecting 4 altogether, there's only 2 more. Does anyone have an idea how many, I might find the remaining 2 zeros of those 4? At this point. At this point, you might want to make it easier on yourself. I don't think you need any more additional testing. In fact, I don't think additional testing would even help you here. We'll see why here shortly. Bill?
You just rewrite it as 3x squared plus 7.
Thank you. He's telling me, Professor, you had this down to a point where you found first 1/3 was a 0, so that dropped that degree of 4 down to a 3. Then all of a sudden, it's a 3 now. All of a sudden, PK gives me a -2, another 0, now it's dropped down to what? A 2, which is going to be what, quadratic? And Philip says these numbers right here, Professor, tell you what the quadratic looks like. It's 3x squared, no x, 0x, plus 27, you can set that equal to 0. No more testing. And solve that. Now if I try to solve this, you'll say, hold on, there may be a problem here. Let's move the 27 over, divide by 3, x squared equals to, looks like a -9. Andrew, did they say find the complex?
Find the complex.
Yes, that opens it up. So i's can be used here. Now if I finish this up, guys, take a square root, plus minus, square root, -9, which is best expressed as?
3i.
Yeah, there you go, plus or minus 3i. Do we agree? Okay. Now, let me list all these all together. I've got a -2 to put in here. Now, if I separate those with the I got a positive 3i and a negative 3i. Close that up, and those are my 4 zeros. Got it. That wasn't too bad. This one wasn't too bad. Okay. Now, Andrew, tell me, did I have on that handout after you find the zeros? We have them. Did I say now go back down, put this in factored form? Or did I?
I don't see that.
You don't see it? Okay, we're gonna do.
After that, it pops up the conjugate pairs.
Ah, beautiful, beautiful, hang on just a second. Okay, let's first try to put this one back together, guys. Do you know the 4 zeros? Now, can anyone with those 4 zeros staring at me there in that set, can someone come up with a way that this function would have looked written in factored form? I'll give you a hint. Anyone give me a nice factor that you know would give you 1/3, which was my first 0, and I'll write that factor out. What would be a nice factor? Do it again. I think you said. I love that. Look at this. She's telling me, Professor, 3x minus 1. Well, if you set that equal to 0 and solve, you get 1/3. Now, how about a nice factor to give the -2? So working backwards. Yeah, it's gonna be x plus 2. 3i, what do you think I could write simple to say now we need 3i? Come out from a factored form, x minus 3i. And the last one's what? X plus 3i. And there it is in complete factored form. But you gotta find the zeros first, which we did, we put it in factored form, there it is. Now to slow down, Andrew, read the conjugate pairs theorem.
Okay. Suppose f is a polynomial function whose coefficients are real numbers. If r equals a plus phi is a 0 of f, the complex conjugate r equals a minus phi is also a 0 of f.
Okay, so it's a plus bi, from that
Oh.
I is the imaginary unit. So if you see something that comes out like in the form of a plus bi, oh, I love this theorem. Automatically, another 0 will be a minus bi. They come in pairs. So if you look out and find one with an I in it, form its conjugate, they call it, and it also will work. Now, did it work here with what he read to me? This right here could be written as, you wouldn't have to, but it could be written like this. To make it look more like what he just read to me. And if that happens, automatically you get this. As he read to me. They come in pairs. So 0 plus 3i, 0 minus 3i, that's a plus bi, he calls it, then a minus bi. Okay? And so now we have all 4 zeros, conjugate theorem done. I put it in factored form, and guys, I think it's nice. I would love to. We could do it. I would love to graph this. In the black there. I'd love to use end behavior, use my zeros, try to find the y-intercept, find the end behavior, what else should we find? Maybe the number of turning points and so forth and so on. It could be graphed. I don't think I might have the time, but we know how to graph it if we had to, of course. Guys, any concerns here? This falls right into place. Yes?
How does that theorem work, actually? The conjugate pair theorem, how does that work?
What's that now? Yeah.
How does the theorem work, actually? Like, how can we say that?
Oh, I got you, hang on. Let me ask Andrew. Andrew, was there any example after that about this?
No.
Yeah, I just threw the theorem in, did not give an example?
The next thing is find a polynomial function with real
There we go, that's where, hang on, there we go.
Is that-
Now, Andrew, depends on you a lot here. Part 2. Now, from that handout, I think, if I'm not mistaken, I gave the zeros to you.
Oh, yeah, they give in degree and 0.
Yeah, I gave you the degree, the zeros, now I'm asking you to go backwards, you write the function. Okay, what did I, on that one, Andrew, give you?
For the first one, it's a degree of 4.
Wait, hang on a second, this has got to be a degree of 4.
And then the zeros are 3 with a multiplicity of 2.
Hang on now. Zeros. You said 3, a multiplicity of 2?
Yeah.
Okay, hang on. We know what that means, tell me more.
And then it's with a negative I.
Oh, negative I here,
Yeah.
and that's all. They get the zeros to me. Don't be a recue business here going on this one. But they want you now, with that information staring at you, now write it in factored form, or write the function. So guys, they want you to find the function, find v of x. And it's gonna be a degree 4. Now, can anyone start me out in trying to form the function based on, he says we have 3 as a 0, multiplicity of 2.
3x squared.
Oh, I know why you said that. Be careful.
X minus 2 squared.
Again.
X
Okay, x subtract 3, here we go. Squared. That will give me 3 twice. True, guys? That's a multiplicity of 2. Now, right now, the degree at this moment is 2.
Yeah.
But the degree altogether is supposed to be 4, so we're not quite finished. Can anyone give me a nice representation to get that to come out as a factor? Yes.
I'm not sure, but is it x plus I?
Oh, hang on, hang on. Ooh, it is x plus I. Gee.
And then also x minus?
Now, she says with the pairs, the other one has to be professor, this one. Because if Andrew read negative I is a 0, automatically positive I is also a 0. They didn't list it for you, but automatically they come in pairs. So they give you one, you can quickly change it to form the other. And Gia, give it to me correctly here. Looks like this. There it is in factor form. And by the way, if you check out the degree, I see a 2, a 1, a 1, I'll end up with a degree of 4. Is that true? Now, Andrew, did I ask anything else of that problem? I'm going to ask something I may not have placed on there.
No, but you asked more on this.
Okay, hang on, just 1 second. Before I leave this one, I love this one, it's finished. But, if I say on your quiz or exam, or you're gonna have a knockout exam next Friday, suppose I say, hold on, what you've done is beautiful, but do not leave an I in your expression here. They're in there right now, but suppose for some reason I don't want to see them. I don't want you to see the I's in the final answer. Well, you say, Professor, this x subtract 3 squared will stay just like it is. There's no I there. So you're concerned about this. I am. For some reason, sometimes we like to get rid of the I. Now, can anyone come up with a nice, quick way from across the street, algebra, to maybe get rid of those I's on the end?
X squared plus 1.
Oh, tell me again.
X squared plus 1.
Whoa! Now, let's see why it is. Guys, this is like A plus B. And this is times A minus B. That's what it looks like for middle school. And if you multiply those two together, I know and you know, that's A squared minus B squared. Where A is X, so this is X squared. Subtract, and B in this case is I squared. I heard what you said here a second, right. Now, the I is still there at this moment. I just did some basic multiplication, like I did with the squares from across the street. Now, if I go further, someone's going to help me out here. I know and you know I has been established as that. What do you think I squared is? If I accept I as square root negative 1, then I say square it. What do you think I squared would give me? Negative 1. You square that square root, the square root drops off. So now I have a replacement for I squared. It's negative 1. Therefore, I can now get rid of that I altogether, write this response as x squared, subtract, in black here, negative 1. And one of my students said, Professor, I knew that to begin with. He gave me real quickly, x squared plus 1. And therefore that would be right here. Another way to express the function without the I. Make sense? Okay. Andrew, did you say I had something else to look at in that particular part?
Well, on the second one, you gave us a value for P as like a.
Oh, I gotta do another example coming up here.
Yeah.
Oh, hang on. Okay, let's call this part 3, because I always do a good job in this. Tell me what it says.
It says the degree of 5.
Oh, hang on now. Degree of 5.
With 1 0 with a multiplicity of 3.
You mean to say one?
Yeah, sorry, zeros and then it's one multiplicity.
Oh, zero is a multiplicity of three?
Yeah.
Okay. I don't know what that means. Give me more.
And then, one plus I.
Oh.
Oh. It's a one instead of a zero.
Oh, out here.
Yeah, it's just labeled as the zeros, and then it's a one.
Oh, I got you. And then out here I said those were the zeros.
Yeah.
Okay. Now, did I give any more information besides that?
Oh, yeah, and then you wrote at the bottom, and P of two equals -6.
I love that. And, besides all that information, P of two is equal to a -6. Now they want you to take all that and write a polynomial function. The degree must be 5. We'll do it. There goes. P of x, we're looking for it. Degree 5, he gave me zeros. He says, Professor, a 0 is 1, but it's a multiplicity of 3, so it shows up 3 times. Does anyone have any in mind what that factor may look like as I try to build this polynomial function up? What would that look like to express this? X what? Is plus or minus? It's x minus 1 and cubed. That would take care of this. That shows me how we get 1 3 times. Is that true? Now I'm gonna be very, very careful. Watch on this one. Does anyone at this point have an idea of what can I write here as my next factor to get that 1 plus I to come out?
X minus 1 minus I.
Oh, I love it. Hang on. You tell me, Professor, if you set this right here equal to 0 and solve for x, in other words, move everything to one side, have x by itself, you'll get 1 plus I. Now, we need one more, and I'll tell you why. In fact, you may tell me why. It's supposed to be degree 5. Right now, if I count, this is 3, that's 1 right there, exponent. So right now, we're at a degree 4. So something's missing. Can anyone tell me what the other factor may look like, even though they did not really tell me much more? What might the next one look like? And for what reason? Well, they gave me 1 plus I, and Andrew just read to me, these come in pairs. A plus BI, right? This one turns into quickly what else is to be included? 1 minus I. There's your other part that they did not give you. They come in pairs based on this. They're called conjugates. Now, if I do that, guys, can anyone be very, very careful? Very careful. Anyone tell me what could you write over here to get that to come out?
X minus 1.
X, I'm here, X plus, or plus. Is it plus 1 or minus 1? Okay, minus 1. And what I heard, what was it, plus?
Plus I.
Thank you. Exactly good. Right? Mathematics. Mathematics. Now, he said, great, Professor, don't stop there. That looks beautiful, get a little partial credit for this. And we're going to finally get rid of that I. He said also, Professor, when you replace x by 2 in your answer over there, you're supposed to get a -6. I could do it right now. I could replace all those x's by 2, crunch that out, and set it equal to a -6. What do they ask me to find with that additional information that I did not worry about finding over here? So tell me, what are they asking me to find that comes out rather than what I did on this one? That's what this will give you when you do it. That did not happen on my previous problem. Wonder why I give you that. It's going to give you the leading coefficient. Mine, on this last one, was not interesting for a leading coefficient, it was understood to be a 1. Now, I wonder, is it gonna be a 1 here? Or does this right here, information change that? It might be a 3 out front, like this thing over here was. Might be a -2 out front, or some coefficient. Okay, let's do this, guys. You could, I have students right now, I guarantee you, if you went through and replaced all the x's by 2, I know it looks strange, 2 here, 2 here, 2 here, and do your business, you could eventually find what's gonna happen here and set it equal to a -6. You can solve and find out what that is. Now, you say, what am I looking for, Professor? I'm looking for this leading coefficient, I'm gonna call it A. Didn't have to worry about that on the last example. A was 1. So I'm looking for that leading coefficient, so let's call it A. Would you guys like to go ahead and go through and replace all the x's by 2 as he gave me and set it equal to a -6 at this moment? Want to do that? Or would you rather get rid of the i's first? Then replace by 2? Get rid of the i's, here we go. Let's rewrite the function. Down the side here, let's write p of x. Here goes, A out front, I know I'm looking for a coefficient. X subtract 1 cubed, it stays like it is. Now, look at this. Students are saying, Professor, get rid of those i's, and then we'll finish the problem. We'll replace x by 2. Boy. How am I going to do that? How am I going to talk like you to maybe rid this thing of these i's? See how it is?
We can pair the x minus 1 as 1 term.
I could, okay, I heard what you said. I've had some students also say this, I'm gonna make it a little bit easier. Some of my students in the past have said, Professor, you can go through and multiply x times all these in blue, and then multiply everything in the blue by -1, like a distributive property, and then multiply everything in blue by the -I. That would work. I see something easier. That's what's gonna happen here. Suppose at this point I group like this. And now I have this in the form of, if I'm clever, I have this now in the form of, look at this, A subtract B times A plus B.
A minus 1 squared.
Which is what, A squared minus B squared for middle school. In the red, that's A squared minus B squared. And I think I'm getting a response already. A in this case is x subtract 1, put that in. Teach you a little trick here, useful. Subtract B, B is I squared. And then multiply it out. Now the first part expanded, not too bad here guys, it's x squared subtract 2x plus 1. X minus 1 times x minus 1. Don't finish, stop there. It says now subtract I squared, and we established I squared back here was -1. So let's put a -1 in for I squared, substitution. All that together, guys, if you agree, is x squared plus 2x. Anyone tell me what's on the end if I put these together? 2. Turns into 1 plus 1. 2. Yes or no? Okay, so at this point, guys, we're bringing it up here. P of x without the I looks like this. X subtract 1 cubed. And I ain't gonna put my A in there because this one just asks me to find an A. Squeeze that in. And the other part, we just cleaned it up a little bit and got x squared plus 2x plus 2. And that's the way it looks at this point. Is that true? At this point? Yes.
It's minus 2x.
What's it now?
X square minus 2x plus
Is it a minus? Oh, minus. Thank you. Right here. X squared minus 2x plus 2. Is that true? Woo! Now, let's do what Andrew asked me to do. Let's now consider this. Which says now replace x by 2 and said it equal to a negative 6. Is it a little bit easier for you to replace x by 2 now in this form than the form that had the i's in them? It's up to you. I cleared the i's out first. Let's go through, find p of, he says, p of 2, which in this case will look like this, guys, replacing x by 2. Be very careful. Looks like that, if I have no mistake. P of 2 in this case will be that's going to be a 1 cubed. On the end here, if I've made no mistake, it's 4 subtract 4. They drop out, do they? That leaves me a 2. Is that true? So far, so good? Keep in mind, we're looking for the A value. Well, he says, Professor, that's equal to a negative 6. They get it to me. So P of 2 right here, now can be replaced by a negative 6. Is equal to, actually on the other side is merely 2a. Now I can solve for a. Divide by 2. I get this. Oh, what a problem. Now, someone in this clever class tell me, what's my final response? What's the answer?
P of x
P of x equals?
minus 3
Beautiful.
x minus 1.
X minus 3. Oh, that's squared. And if I say leave no I, what would you use?
And then x minus 1.
X minus
Oh,
one.
now, am I doing the wrong problem?
X minus 1
Okay, we'll have it all, hold on. Oh, I was looking at this problem up here. Did we change this?
X minus 1 cubed.
I mean, out here, x minus 1 cubed. That's what she said. Let's get your act together. Here we go. X minus 1,
cubed.
no, the wrong problem, cubed. And
X minus 1.
x
X squared
minus,
minus
could we
square.
write as x squared minus 2x plus 2?
Yes.
Wow. Okay, is this what you're saying here? Okay. Woo! But first, do we agree with that much? Do we agree with that or not? Okay, now hang on. And now let's see what she's concerned about. Now guys, I know if I were a student, I'd say, Professor, should I check this? Now, you would have to check it by doing this. You'd have to multiply this out from algebra 1, algebra 2, middle school, multiply, and it's messy. And it should take you right back to where was I when I wrote all this down? I'm all on the board here. Where was it? Or was that it? Oh, and Andrew, you gave me some information here. It came from here, right?
Yeah.
Yeah, it came from here. You could multiply that out. I'm not gonna ask you to multiply all that out there. PK.
So what if you don't solve for I and just put P of 2 equal to minus 6?
Got you. And she says, Professor, suppose you did not get rid of the I, and just leave it in the I, and say, take it right there. Here we go. And you're gonna say, well, P of x is equal to now. Your question here, x subtract 1 cubed. And she says, Professor, leave it in the original form. 3K did not, let me make a mistake here. Bounced up the board. You're saying that? And she says, Professor, suppose you didn't multiply it out like you did to get rid of the i's, and you did it right now. In other words, you did this. P of 2 is equal to a negative 6, so the score ahead says this is negative 6. Of course, you're looking for the A, the coefficient. And she says, Professor, suppose you go through now and replace all those x's by what was it, 2? Okay, 2 subtract 1 cubed. 2 subtract, got 1 minus I. 2 subtract 1 plus I, right? She's doing it another way here. R is negative 6, it's equal to the coefficient I'm looking for. This is 1. Now, this business. If you want to do it like that, you got 2 minus 1, which is what? 1 minus I? And then what? 1 plus I? Now, could I multiply these two together fairly quickly? Is that 1 minus I squared? Like A squared minus B squared. And I squared, of course, is what? Negative 1? Does that come out to be a 2 there? So she would have hers as negative 6 is equal to, what was it, 2a? And there, a is negative 3. Again. That's what you're thinking? That exactly, you can. You can. But now if I have on the exam, after you do that, but do make sure your function, where is it? Up here, has no i's in it. Your final answer. I had, what was it, negative 3 out front, there it is. Oh, up here. We have no I in it. But no, you could do this business. Okay. Got any concerns there? Wow. Andrew, is there anything else on that? Whoa, you said, that's enough. Right there. Polynomial functions. Now, what I could do, I doubt I would do it to you, because you have enough to do when you see a quiz or an exam on this information. I could say, now, graph this. Graph it. Check out its end behavior. Try to find the, well, you have the x-intercepts at zeros. Yeah, graph it. There's a graph there. Or you can graph it. But I want you to do it on this one. Give me one big reason why I would not want you to do it on this one, even though there is a graph. Why would I not want my students really take the time to try to graph this one? Even though there is a graph for it. Well, might throw you a little bit. And can anyone tell me what are the x-intercepts if I were to graph that straight thing? Where are my x-intercepts? 1, 0. 1 comma 0. I just have one x-intercept. I said, wait, Professor, I thought you were supposed to have, where was it? Degree was what, 4?
No, it's
what?
every 5.
Oh, now your degree was 5. And you're saying, wait, Professor, that degree of 5, that's up here, right? You say, well, okay, you have just one x-intercept? I thought you're supposed to have 5. Where are the other 4? Where are they in here? Oh, one x-intercept. This right here, if you set this part right here equal to 0, and try to find another x-intercept, guess what you get here? Imaginary numbers. All right? You're going to get imaginary numbers. So there is a sketch. I'm not going to ask you to do it. With only, it looks like it should be a more complex sketch. I bet it would look so strange because it has only one x-intercept. Located at G, I think you told me, at 1. And then go through the end behavior and so forth and so on. That's all it has. I can't use those imaginaries as x-intercepts. They're not on the x-axis.
Could that be simplified even more?
Like what?
Well, what doesn't the end one factor out to
Oh.
the same as,
Tell me what you think it is.
well, it factored out the x minus 1 squared, right?
Whoa, 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 whoa. Andrew. X minus 1 squared is x squared minus 2x plus 1. We want x squared minus 2x plus 2.
Yeah.
Okay? That was not factored. I wish it would. Guys, we're finished with this one. I think we're finished with the polynomial functions. Wow. Now, you say, Professor, what's next? I'm just getting used to polynomial functions. I sketched some for you guys in behavior, x-intercepts, cross, touch. We did all that, didn't we? Where it crosses the x-axis, touches the x-axis, all that business. What else is there, Professor? Well, here we go. I've got a nice handout for you, as always. Now, guys, hang on to all these notes, especially the handouts. One of my former students says his roommate in college wanted to use them for the course he was taking. I thought, oh, great, so you've been using the notes that we have here, SMC, your handout. Yes, Professor, my roommate from a different school likes those notes we have. Great. Then he told me the roommate had to pay him. I said, oh, you can't do that. You can't do that, you can't sell this. Oh, how do you want to sell these notes? Handouts. And not give me some profit. I'm more concerned about me, where's my profit? Out there trying to sell something. No. Anyway, his roommate liked these for his course. Now, let me see if I have all my handouts available, staring at me here. I do. Before I pass it out, I've said many times here at SMC, and I think they're finally going to do this. I said you should name this course functions. I know they like numbers here at SMC, Math 2, Math 7, Math 8, Math 11, they like numbers, Math 15. I said, why not rename this course functions? That's all we're talking about, functions, functions, functions. Before I pass this out, which is another set of functions. Our little recap, let's name a few functions. We did quadratic functions. They use word functions on quadratic, so we did quadratic. We did polynomial functions just now. Did we look at an absolute value function? Did we look at, help me out, guys, I named those. What else? Did we look at? Square root function. They love to place the word function on these. And here goes another set of functions. Now, these are not as well behaved as polynomial. Now, before I pass this out, we get into these. Those polynomial functions, when you graph them with the in behavior and the cross touch and all that business, did you notice they were all nice smooth curves? They start here and go down, and go up like that, come back down, something like that. It's nice and smooth. These aren't. These are not well behaved. They jump. Something like, almost like a piecewise function. Remember that piecewise function I gave you guys on the test? Now jump, you get one piece here, and all of a sudden another piece over here, and a piece down here. That's what these do. I think we've got a little few rules here to follow to graph this. Now guys, we'll try a couple of these. Don't want to wear you out on this. And then probably move on to another topic, and then come back and finish this up a little bit later. Okay? Mr. Parker, will you help me out?